Hello, Honors Algebra students. Mr. Lawrence here, and this is the third review video. This one should go a little quicker. The other problems took a little bit of time. These won't take as long. All right, so we're going to be solving quadratics, and we know different ways to do it. One of the ways is to solve by factoring. So I'm going to go through here and check and see. I've got three terms on this first one. I don't see a perfect square as A or C, so this is where I'm going to list out the factors, 1 and 15, 3 and 5, and then I'm going to list the factors of 8 as well, 1 and 8, and 2 and 4. Hey, by the way, if you're really bad at your factoring and you haven't come in for help, you might want to check out the level 2 video. Sorry about that, the bell just rang. The level 2 video, Algebra Level 2, all about factoring. It should be posted pretty close to the same place so that you can get a little refresher on factoring. All right, so I am going to multiply one of the factors of 15 with one of the factors of 8. I'm going to multiply their partners. My goal is to subtract to get a 14. And so let's see, 15 times 8, that'd be way too big. 15 times 1 minus 1 times 8, no, that's going to be a 7. 30 and 4, no, 15 and 4 is not going to work. I don't believe I'm going to use these two. I think they're just too big. Let's see here. How about 3 and 8 is 24 minus 5. That's not going to work. 18 minus 5, no, that's not going to work. Oh, wait a minute. How about 5 times 4, which will get me 20, right? And then 3 times 2, and that'll get me 6. Now, because C is negative, I want to subtract. Do I want to do 6 minus 20 or 20 minus 6? Well, because B is positive, I want 20 minus 6. So, here we go. All right, I'm going to do two quantities, right? And the 3x and the 5x are going to lead each quantity. They're not both in the first quantity. No, that'd be an 8x. But they're going to lead the first quantity, each quantity, right? Okay, now 5, don't forget your little loop and your big loop. And the 5 gets multiplied by the 4, so I need a 4 right here. The 20 was positive, so I want a positive 4. The 3 gets multiplied by the 2, so I need a 2 here. I wanted a negative 6, so it'll be a negative 2. Now don't forget to leave it equal to 0. Now I'm going to use the zero product property, right? So I'm going to say 3x plus 4, something is wrong, there we go, equals 0, and 5x minus 2 equals 0. I'm going to solve each of these for x, and that will tell me my two solutions. All right, so it looks like x is going to be negative 1 1/3, or x could also be 2/5. And those two answers will be the solutions or the roots, right, of the quadratic. Okay, number 2. To factor. If you'd like to pause the video and try it on your own, go right ahead. Here comes my solution. I know I'm going to factor an x out of a GCF, but I think there's going to be more than that. Oh, let me see. I'm going to list the factors of 75. So I'm going to get 1 and 75. 2's not going in. 3 is. 3 and 25. 4 doesn't go in. 5 does. What is that? 5 and 15, I think. Let's see. Yeah, I think that's right. 6 can't go in because 2 doesn't. 7 doesn't go in because 7 times 11 is 77. 8 can't go in, it's not even. 9 can't go in because 7 plus 5 isn't a multiple 9. 10 doesn't work. 11 doesn't work because 11 times 7. 12 can't work because 4 didn't work. 13, I don't think so. If I do 13 times, say, 6, that would be 78. That's not going to work. 14 can't work because it's even, and I'm back up to 15. Now, of course, you're allowed to use a calculator to help you figure this out. So now I'm going to ask myself, is 75 a factor of 180 and 108? No, I don't believe it is. How about 24? I don't think so. 24 times 5 would be 120. 24 times 4 would not be 108. So 24 is not going to work. 15 can't work because it's not going in 5 times. 5 is not going to work. 3 must be it. So I'm going to pull out 3x out as my GCF, and I'll be left with a 25x squared. I like that because it's a perfect square. Now, that'll be a what? A plus 60x, right? And then plus, let's see, 108. Let's see, if I had 3 is going to go into 10, 3 times 36, I'm thinking. All right, so now I check A and C, and they're both perfect squares, right? That doesn't mean that it'll factor, but I'm going to check. The square root would be 5x, and here will be 6. If I multiply those two together and double it, I get 60x. So this is going to factor really nice. This is going to be 3x out front, 5x, and a 6, and then a 5x, and a 6, or you could have written one quantity. There's a plus in the back. C term is positive. B term shows up twice. It's a Wendy's double stack. There you go. So now I have to solve each quantity, although one of them is redundant, repetitive, so I don't want to do that. I'm not going to waste my time doing that, I mean. Where'd my eraser go? Made a silly mistake there. All right, so we're going to have 5x plus 6 equals 0, and I'm not going to write it down again. All right, so I'm going to solve for x here and get x equals 0. That's one place it'll cross. And another place it'll cross, looks like it'll be x equals -1 and 1/5. Yeah, I believe that is right. Okay, third one, please feel free to try it on your own. Pause the video. All right, looks like I have the difference of perfect squares, so this is going to factor as 4x plus 5 and a 4x minus 5 equals 0, and so I'll have to solve each of those. And when I do, I'll get a -1 1/4, and I'll also get x equal to a +1 1/4. I'll get 2 solutions there. That's solving by factoring. Gotta know your factoring. All right. Of course, we could complete the square. Now, this one's pretty easy. I usually want the C term to be on the right-hand side of the equal sign. And I need the A term to be 1, right? And I'm going to force this to be a perfect square trinomial. So I'm going to have x squared minus 14x, leave a little blank, and I'm going to take the the 16 over to the other side, thereby making it negative. All right, so now I take half of b, right, and square it, so that'll be 49. Okay, excuse me. So then I have to add 49 over here. I've got a perfect square trinomial on the left, so I'll have x minus 7 quantity squared, and then I'll have a 33. All right, take the square root of each side, right? And so I'm going to get x minus 7 equals plus or minus the square root of 33. That does not break down. 33 only has 2 factors because it's prime, and so I won't be able to have a date or take anybody out of the house. So I'll get x alone by adding x to both, or by adding 7 to both sides, and this would be my exact answer. Of course, if they asked for a decimal, I could plug 7 plus the square root of 33 in, and 7 minus the square root of 33 in. Okay, square root of 33 is probably going to be in the high 5s, probably around 5 and 75/100ths, somewhere around there. So, you know, it's going to be about 12 and 75/100ths, and then maybe 1 in 25/100ths, something like that. Okay, this one here. First thing I'm going to do is I'm going to get rid of this 4 and see what happens. Yeah, I know I need a to be 1, but I'm going to get rid of that 4 first. It might make my life easier. So 3x squared plus 8x, subtracting 4 from both sides will get me 96. I like that because now I'm going to divide everything by 3. Okay, and when I do, I'm going to get x squared plus 8/3. I'm not going to a calculator. I'm going to leave it as is, 8/3. I like 8/3. I'm not afraid of fractions. It's going to make my job easier. 32. Okay, so now I take half of this, which becomes 8/6, right? I'm going to simplify 8/6. 8/6 will become 4/3. And then I'm going to square it. And when I'm sorry, I don't want to do that there. I don't want to put 4/3 there. I want to leave 8/3 there, sorry. But I do want 8/6, and 8/6 simplified is 4/3. And when I square 4/3, I am going to get 16/9, right? If I square it. Sorry, I lost my equal sign there. So I'm going to put a 16/9 here, and I'm going to add 16/9 over here. All right, so this is going to be a perfect square trinomial. Now,
teachers, please excuse
this number here is the same as 4/3.
There is no Big Brother or Big Sister Club this afternoon, or Boys and Girls Club. I'm sorry, there is no Boys and Girls Club this afternoon.
Quantity squared, right? Because remember, this number here, when I take half of it, is what always goes there, right? Half of 14 was 7, and right there is 7, right? Okay, now that's going to equal, I'm not sure how many ninths that is off the top of my head, but let's figure it out. 32 times 9, so that's going to be 8, carry the 1, 27 and 1, 28, should be 288. So this is going to be, excuse me, this is going to be 288 ninths. All right, let's take the square root of each side and get x plus 4/3 equals plus or minus the square root of 288 over 3, right? So now I'm wondering if that 288 can be simplified. I'll bet you it can. But let's see what's going on. I'm going to have x equals negative, I don't know why I wrote it over there, negative 4/3 plus or minus the square root of 288 thirds. Now I'm going to come off to the side here and simplify that rad 288. No, that's not the prettiest one, but 144. Hey, isn't rad 288 the same as 144? Rad 144 times rad 2, and this is 12, right? So what I really have going on here, I'm going to write it as one fraction. I'm going to have negative 4 plus or minus 12 times the square root of 2 over 3. This cannot be simplified any further. 3 does go into 12, but it does not go into 4. And so if you want the exact answer, there it is. Whoa. All right, so that's completing the square. And finally, everybody's favorite, I didn't do the quadratic formula, but I'm assuming you know how to do that. I'm sorry. If you really need that, let me know. Solving systems of equations. Now, they might come in the form of a story problem, like we did with in class where we made up the area and the perimeter of a square or a rectangle. But to solve a system, I like to use substitution. On this first one here, it says y equals 28x plus 4 and y equals negative x squared plus 39x plus 64. Well, I'm going to use substitution. Now I'm going to substitute 28x plus 4 in for y and make it equal to negative x squared plus 39x plus 64. Now to solve a quadratic, I usually want it to equal 0. So I'm going to take x squared over to the left, and then I have to subtract 39 from both sides, and that's going to give me a negative 11x, and subtract 64 from both sides, and I'll get a minus 60, and that will equal 0. Okay, now I can go quadratic formula, I can factor, or whatever the case may be. So I think I'll go quadratic formula because I don't think I did one of those. I did one in the other videos, but I'll do one here. So first I go A, B, C. Easy as 1, negative 11, negative 60. Okay, So let's find the discriminant. So that would be what? Negative 11 squared minus 4 times 1 times negative 60. And so we're going to get 121 plus 240. And so that looks like it's going to be 361, which I like a lot because that's a perfect square. So I'm going to go x equals negative b plus or minus the square root of the discriminant all over 2a. And when I simplify this, I'm going to get x equals 11 plus or minus 19 divided by 2. So x is going to be 30 divided by 2, or 15, or x is going to be negative 8 divided by 2, or negative 4. There you go. Okay, number 2 is an area and perimeter problem. Perimeter of a rectangle is 162 feet. The area is 1,430 feet squared. So I need 2 equations, right? So let me see. Let me change colors here so my work doesn't blend in together. I need 2L plus 2W, and that has to equal 162. And then I need length times width, which equals 1,430. Of course, I could be using B times H, which I normally do. All right, I'm going to pick the top equation. I'm going to solve for either L or W. Let's go ahead and solve for L. So 2L is going to equal 162 minus 2W. Then L is going to equal 81 minus W. Now that I know what L is the same as, I can substitute it into the second equation. So instead of writing L times W, I'm going to write 81 minus W times W equals 1,430. All right, so as I do this, I'm going to get negative W squared plus 81. And I'm just going to go ahead, 81W, and I'm going to subtract 1,430 from both sides to make it equal 0. And now I can go factoring, I can go quadratic formula, something like that. So I think I'll go quadratic formula again. So A, B, C. Easy as negative 1, 81, negative 1,430. All right, and so then W is going to equal negative B plus or minus the square root of B squared minus 4AC all over 2A. So let's see what that discriminant is. That'll make things a little bit easier. Negative 81 plus or minus the square root. I'll bet it's going to be a perfect square. I just have this hunch. All right, so let's see. 81 squared minus 4 times negative 1 times negative 1, 4, 1,430. And when I do that, I get 680. Ooh, I don't know if that's a perfect square. That doesn't seem familiar to me. I wonder if I have a silly... Oh, I do have a silly mistake. I did 80 squared instead of 81 squared. All right, let's try that again. There we go, 841. Now, I don't recognize that that's a perfect square, but I have my calculator. I did know that the previous one was not a perfect square. So let me see here. What do I got? The discriminant is going to be 841. Interesting. I wonder what it's going to be. I'm hoping it's a perfect square. Otherwise, I have some mistake. Yep, 29. There we go. Cool. All right. So W equals negative 81 plus or minus 29 divided by negative 2. Now, I'm only going to be interested in positive answers. But watch what's going to happen here. Negative 81 minus 29 is going to be negative 110, right? Negative 110 divided by negative 2. So the one width could be 55. All right, if I do negative 81 minus 29, well, that's going to be 52, I believe, right? Negative 52, because it should be like that. So then I'm going to have W equals negative 52 divided by negative 2, which is 26. So either the length or the width are 55, and then the other one is 26. But let's check it. Let's do 26 times 2 plus 55 times 2. And if I get 162, I'm feeling really good about my answer. And sure enough, I do. Let's try the length times the width. 26 times 55. I'm hoping for 1,430. And I got it. Excellent. All right, I think that's it for the video. The solving by the quadratic formula was pretty much built into some of the other problems. All right, so there's 3 review videos to help you get ready for Monday. That's it. Mr. Lawrence signing off. Have a good night, everybody.